Hey, 7th hour physics class. Sorry I couldn't be there today. I wanted to go through some of the problems on the worksheet that I assigned yesterday. The kinetic friction and the static friction problems. So for the first few problems, we're talking about finding the coefficient of kinetic friction. We have an applied force that's making a box move at a constant velocity. Normal force, weight. After you draw your force diagram, F net x, so we're going to get FA minus kinetic friction equals ma. In the y direction, n minus mg equals 0. Since we're moving at a constant velocity, a is equal to 0. So that's going to equal 0. Now what I suggest for every problem that involves friction is that we solve for the normal force. So in this case, n is equal to mg. I believe the first problem says it's a 500 Newton box, so that is mg. In the second problem with Meathead Mike, the mass is given at 100 kilograms, so you'd have to plug that in for m. So now that we know what n is, 500 newtons, the next step is to take our x equation and substitute mu k n in for friction, and that's going to equal 0. And now if we solve for mu k, we're going to get F applied over the normal force, just like we did with the lab. And in this case, it's going to be the applied force, which I believe was 66 newtons over 500 newtons, and that will give you our answer for the coefficient of kinetic friction, mu k. Now, when we're dealing with static friction problems, the only thing that's going to change out of this whole picture is that right there, the k. We're going to erase that over here, change our values, and we're going to replace that with an s for static. In all static problems, acceleration is equal to 0. Still, first thing you want to do, solve for the normal force. Then take the x equation, and instead of having mu k, we'll get rid of that too. You're going to have mu sub s, mu sub s, mu sub s. Try not to fall into the habit, though, of always assuming that n minus mg is equal to 0 and that the normal force is equal to mg. Remember yesterday when I gave you this problem, and I asked you to write the x equation. Well, if we were to write the y equation for this, it would look like this. N is in the y, mg is in the y, but so is some of the applied force. So the y equation would look n plus Fa sine of theta minus mg equals 0. So here the normal force is equal to mg minus fa sine theta. I will go through this whole problem on the other YouTube video, so I'll stop here with that. I'm just trying to point out that you don't always get into the habit of thinking that n is equal to mg. Have a great afternoon. See you tomorrow.